On page 302 is our final type of application that the book gives us for logarithms and exponentials. And this is a very useful equation. It's Newton's law of cooling, which talks about how you can determine the temperature of a medium after a temperature of an object when placed in a certain medium and how it cools over time. So in the example with number 52, we're talking about a cup of hot chocolate that was measured its initial temperature, and then the temperatures were measured over time after it was taken out of the hot chocolate and then put back in, and it was placed in a saline solution where the initial temperature of that medium was 0 degrees centigrade. So we were given a table of the temperatures and the change in temperature, and we were asked first to draw a scatter plot and find a line of best fit. So in the Inspire, I went ahead and created a scatter plot using a list in spreadsheets. So I labeled my first column as time and my second column as T difference for temperature difference. So using the first and third columns in the table, I put in all of the different times and the temperatures that went along with those. Then what I did was add a data and statistics page, and I created my scatter plot, and that would be part A, would be the blue dots. And I have my scale there, which would be easy to copy down on my paper. And then after that, part B asks you to find a exponential regression equation and put it on your scatter plot, which I did here. So we can see our regression equation is y equals 79.9607 times 0.927288 to the x power. And now in part C, we're asked to estimate the thermometer reading when it was removed from the hot chocolate. So at that time, that would be a T equal to 0. So when I substitute that in, I will get y equals 79.9607 times 0.927288 to the 0 power, which is just going to be, and if I round, I get the value that the initial reading of the hot chocolate was 79.96 degrees.